In this tutorial, we're going to take you how to run a naive Bayes model on a dataset. The dataset we are going to use is a sample dataset. It's called Boston50.txt, and it is a generic dataset created for this type of tutorial, so for classifiers. So the naive Bayes model, we'll just get started here. Initially, we want to import all the libraries that we are going to need for this model to run. So we can see there's a Spark context, naive Bayes, ML utils, and labeled point. And we also will need array. So from NumPy import array, we will need that for the machine learning utils, so the ML utils. So we're going to start here, Shift Enter to run it. In this next section, you'll create a file path. So in this file path, replace what is in the tutorial with wherever your data is located, and then in the following line you can call sc.txt file and call that file path to create your RDD, and then soon after you can cache it. So our data is currently tab delimited, and we have chosen for this tutorial to replace those with commas. So we'll make a new B, map. And so just a simple line.replace. And after this, we're going to create a function, and the purpose of this function is to go through each line in our data set and return the labeled point, which is one of the functions we have imported. This just specifies which column in or which variable in our data set will be the predictor variables and which one will be the outcome variable. So we're going to split the lines of comma here. And then this labeled point is the one that we have imported. And the 13th column in our dataset is the one that is specified as the class, so that's the outcome variable. So we're going to define that right there, and the rest of the columns, so 0 through 12, will then be the predictor variables. So now we're just going to call that function. Looks like it's working. So the next thing we want to do before we can run our model is to separate our data set into two different sets. One will be a data set used for the training of our model, and the second one will be the one used for testing the model. So train Boston. And in this case, we're taking a random split, and we will be separating these into 60% of the set will be for our training, and 40% will be for the test. We're now going to call this naive Bayes.train function that we have imported. It's in the naive Bayes library, and then we're going to call upon the training set. So here we will be making our prediction and testing the accuracy of this model. So we'll call this prediction and label Boston. take the test data set and then this calls a predict function, which then takes the features, and this is all imported. So this predict, this Boston model dot predict, and as well as this features, these are both imported in the libraries. And then the label. So this essentially applies the model that we have created on the training set and applies it to the test set. So after this, we can then create the accuracy variable that will show the accuracy. So we'll use this 1.0 to turn it into a float. Prediction. So we're going to call that variable we created in the data set we created in the last one. And then we're going to filter so that the two variables are simple, so that the actual class that was created or that was found in the test, so that the 13th column, we're just going to test to make sure whenever that is equal with what is predicted of it, we're going to keep that data set, or we're going to keep that row. We're going to count how many that is, and then we are going to count how many are in the original set. Alright, and now that that's created, all we have to do left is print. In this case, I can probably just print. Oop. Oh, that didn't work. So all we have left to do now is just to print this accuracy that we have just calculated. And so here we ended up with roughly a 69–70% accuracy. It's not as great as you can get, but in your model it might be better.